Hello, everyone. Welcome. Thank you for joining us today in our marathon seminar session. Today, our topic is the Caribbean king crab aquaculture, a potential solution for the Mesoamerican Reef. So I would like to introduce MAR+Invest first. MAR+Invest, it's a marathon initiative, and it's a blended finance mechanism that aims to invest in market solutions that contribute to the health of the corals in the Mesoamerican reefs. So this initiative is implemented through a strategic alliance of organizations, and it's supported by the Global Fund for Coral Reefs, the GFCR. So the GFCR is a blended finance instrument to mobilize action and resources to protect and restore the coral reefs at a global scale. So I would also like to mention our partners, the MAR+Invest partners, Mexican Fund for the Conservation of Nature, Sureste Sostenible, Healthy Reefs for Healthy People, New Ventures, and Biguala. So today we are going to present one of the portfolio projects of MAR+Invest, the Caribbean king crab aquaculture project, and I would like to introduce the speakers who are the great women managing this project. So Melina, Sara, hello. Thank you for being here with us. Melina Soto, she's the coordinator for Mexico, Healthy Reefs for Healthy People initiative. And we also have Sara. Sara is the technician in charge of the Caribbean king crab project, IMIPAS. So Melina, Sara, thank you, and please go ahead.
Hello everybody, thank you for being here. We are going to present to you the project on the Caribbean king crab, which has become a key ally for coral reef restoration. It's going to be myself and Melina, so let's get straight to the point. Melina, you have had more than 10 years experience working with coral reefs, and I think it's important for you to introduce a little bit of what's going on, put a little bit of background into this story. So if you can start with that, that would be amazing.
Thank you very much, Sara. Yes, I guess everybody already kind of knows all the amazing gifts that the coral reefs give us as humans living on the coastal area. But as a reminder, the healthy reefs that makes this 3D structure by their when they do their calcification of their skeletons, right? The corals, when they calcify, that make all those amazing structure made of carbonate, and that will produce a 3D structure, a barrier that will give us most of those amazing ecosystem services or gifts. So of course, they protect us, they protect our infrastructure, our investment on the coast by being that barrier, but also when they are eroding, they produce that amazing white fine sand, and all that together with the turquoise, crystal clear lagoons, well, also is an amazing tourism attraction, right? And that's in the Mesoamerican Reef. That's all we almost all depend on that activity. But they're also the source of compounds that are used in pharmaceutical industry, and of course they have a great value for cultural value, but also for small-scale fisheries, right? And also the organisms living in coral reefs, but also in the adjacent or associated ecosystems, such as seagrass or mangrove, are really, really effective in sequestrating CO2 from the atmosphere. So in those times of climate change, this is super important. And so a healthy reefs, the Mesoamerican Reef, healthy, generates more than $4.5 billion per year. So this is amazing.
That sounds incredible, but can you explain to us a little bit of what's going on in the Mesoamerican Reef right now?
Yes, exactly. Our organization, Healthy Reefs for Healthy People, has almost 20 years in monitoring the health of the Mesoamerican Reef. And unfortunately, well, the news, as you may expect, are not very great. And one of the main indicators of worry, of alarm, is the fleshy macroalgae cover. This indicator has been rising since constantly since the beginning, and now in all of our 4 countries, it's reaching critical levels. So most of the coral reef structure is now covered by algae and fleshy macroalgae in specific. Yeah, and this is how
that looks
exactly
terrible.
Exactly. And this is how most of our reefs actually look like nowadays. So yeah, it's really something that doesn't look great. So it's not such a tourism attraction, right? But it has also other negative impact on the reef. They compete with the corals because, of course, they grow way more quickly than the corals. Corals only grow from millimeters to centimeters per year, depending on the species. The macroalgae, they just bloom, right, because they occupy the nutrient from the water, etc. And so this will block the access to the light to the corals that need photosynthesis, right? And also will difficult coral recruitment. The baby corals that need to find a place on the reef won't find it. And macroalgae don't calcify, making structure. Some macroalgae calcify, but those fleshy macroalgae don't do this building of a structure as the coral do. So when they occupy more spaces, then we will see the increase of erosion on those structures, and then so every all the 3D aspect of it will compact and erode, and then we will lose all the other gifts that are associated.
Thank you, Melina. Do we have an idea of what is causing this problematic?
Well, yeah, there's several root causes for that big threat, but mainly it's, of course, the climate change, as I was mentioning earlier, and also the pollution from the watershed, from the land all around that coral reef ecosystem. So it's from poor agricultural practice, but also from none to very limited wastewater treatments. And those nutrients like nitrate, phosphate, etc., and potential pathogens, right, bacteria, virus, etc., enter the ocean, enter the lagoon, and reach the reef.
Okay, that sounds like a very big problem, but a lot of room for opportunity to act upon it, right? So can you tell us a little bit about what Healthy Reefs Initiative is doing to address this very critical problem?
Yes, thank you. Yes, indeed, like as you're aware, but I didn't share, the Healthy Reefs Initiative is formed by more than 70 partners, right? So from the 4 countries and international partners. So we are addressing those threats from several points. We attack it from several fronts. And so we will work on a top-down strategies where we are working in addressing the issues relating to sewage treatment, so improving the policies, trying to find funding to help local community connect and make their own wastewater treatment plants, etc. We also, as you know, we monitor the reef health, but also sometimes with some of our partners include monitoring of water quality. And with all those data, we are trying to make strategies to improve management. But we are also focusing on another bottom-up strategy, which is working with what's eating the macroalgae, right? We can't only focus on improving the water quality, because this will take a lot of years to make it internationally. So we also need to improve and restore those herbivorous species that are directly consuming those fleshy macroalgae. So this is, for example, the case of the protection of the parrotfish. We have succeeded the protection of parrotfish in the whole 4 countries. Each of them has their different type of law, but as a region, we protect the parrotfish for its ecosystem services. So, and this is pretty new in the world. But we are also trying to implement pilot projects and restore those populations. And so we have worked with Diadema. Some of our partners are working with Diadema, exactly, with the Diadema, and as I was saying, we've protected the parrotfish. But those 2 main heroes or main herbivores that everybody always work with, or always mention as the top herbivores of the reef, also have like a dark secret, right? Yeah, if you can see their beak or their mouth, they have this really sharp mouth, and they don't really focus on what they're eating. They just scrap the surface on the reef, and sometimes corals also. So our coral reef are nowadays pretty much degraded. Most of our sites are under critical to very bad coral cover. So under those circumstances, with degraded coral cover, we really don't need another menace, right? Another threat adding to the erosion of the whole system.
Yeah, definitely. I mean, they have always been the herbivores that scientists and conservationists have focused on. But as we can see, they have also some very negative effects on reefs themselves. So
yes, and
I know that
sorry.
Go ahead.
No, in a healthy reef, in a healthy ecosystem, this is fine, because it makes room for others and to grow, etc. But in a degraded and critical ecosystem, this can be really counterproductive.
Of course, but I know about it, and we know that, for example, the king crab has come in and made a big impact on how we look at herbivores. So do you want to tell us a little bit about what has been done with the crab?
Yes, well, yes, as you say, and as we can see in the video right now, the Caribbean king crab is really an herbivore that has been overlooked. Not much people have worked with them so far, but as you can see, they are voracious eater, and they are selective. They can pick the algae they prefer, and fortunately for us, they prefer the fleshy macroalgae, right? They don't like scrap or anything. And they have a really diet that they eat a lot. So yeah, that's why we were very interested in working with the Caribbean king crab. And that's why a few years ago, we designed a pilot project. A very simple design, because we just wanted to make sure it was true, because those studies or those words about the effectivity of the king crab as an herbivore, well, were pretty old, or there were not much information about it. So we made that simple design. When we relocated, we moved some crabs into patch reefs where coral restoration was being made, and it was being threatened by those macroalgae. So we decided to help a bit those corals and make an experiment out of it. And it was very interesting because we did see a significant macroalgae decrease, but also the turf algae decrease. And this is very interesting because we don't speak sometimes about the turf, but they make those mats that also sometimes accumulate sediments, etc., and are also that can accumulate disease, etc. So they're also like something that to look out at the reef. But the other thing super interesting we saw is the increase of crustose coralline algae, and those are sometimes the precursor for coral recruit. So that was pretty interesting. We made those pellet studies in Mexico and in Belize, and both gave most of the same results. But we are not like solving anything there, right? We just moved some crabs from one patch reef to the other. If we want to make that a solution, if we want to make that a restoration practice, we need to produce those crabs because their number in the wild are already pretty low. And this is how we made the collaboration with you guys at IMIPAS in order to implement, to see if it was possible, right? To implement an aquaculture pilot and see how difficult that could be. And tell us about that.
Thank you, Melina. Yeah, so after those very interesting results, and as Melina said, we needed to be able to know if we could produce crabs, if there was a way of increasing their populations. So seeing that IMIPAS, the Mexican Sustainable Aquaculture Research Center, had the facilities that permitted it, a pilot study started in which we wanted to produce the Caribbean king crab. That way we could introduce organisms to the reef, intentionally reducing macroalgae to get healthier, more productive reefs. But also on the other hand, we were going to be restocking a valuable fishing resource. It has come of a lot of interest to many fishermen. So it was just adding this new, very interesting resource to the fishing communities. And then that way we would be benefiting local populations by having healthier, more productive reefs, but introducing also this new fishing resource. So it seemed like a very interesting project, but we needed to know if we could do it. So we started 4 years ago with this pilot study. We had the tanks thanks to the IMIPAS facilities. We had a very interesting book by a researcher called Walter Adey, which did a lot of experimenting in the 80s. It was a 300-page, very old book that had a lot of very interesting information, but not a lot on aquaculture itself. So we needed to figure out how to feed them, how to manage them, how to check the organisms. We started a little bit with mimicking what he did in the ocean. So you can see him on the left picture in the top, him holding a big box where they would put the gravid females and wait for the larvae to be born, for the eggs to hatch. So we were basically imitating this process. You can see us with a similar kind of box. And there was a period called the Act of Faith. It was not only an act of faith because of the whole project being so new and everything so unexplored, but it was an act of faith because when the crabs are juveniles, they are made so they can hide from the view of any predator, including our eyes. So an act of faith because, believe it or not, in these two pictures, Melina, could you spot the two crabs that we can see there?
Me, yes, but because I know where they are already. But no, that's true that the first batches, we really thought we had like missed it. That something went wrong and that we didn't have like succeeded in having juveniles.
Yeah. So it was an act of faith because imagine looking at your substrate and just seeing or finding these, like even with the arrows, it's hard to identify and like really understand that there's a crab right there. So from seeing them to feeding them to just understanding about the species, it was a lot of learning and a really big, interesting process. From starting from the reproductive process and how the eggs developed, how long it took, how well they developed in our systems, and if it was actually possible to get reproductive activity in our systems. So you can see both the eggs looked at in the microscope in the pictures above, and the eggs inside the female abdomen in the pictures below. And now we've come to understand the coloration of the eggs and know exactly what phase they are at based on their color. It was a very, very intense process of understanding what was happening with the eggs. We have also seen them grow. You can see them in that first picture on the left at the top, how tiny they are. And sometimes you don't really know if what you're looking at is a live crab, a dead crab, a mold, sand, or any other thing that might have gotten into the net. But as they grew a little bit more and we trained our eye, we started to be able to see them grow and start understanding how quickly they grow and how much time we needed to have crabs to be able to introduce on the reef, which was, well, our mission, right? So what we would do is we would grab the molts, as invertebrates, as crustaceans, they have an outer skeleton that in order for them to grow, they have to get out of that skeleton. So we would get that remainder skeleton and measure it. And throughout time, we created this growth curve, getting very, very interesting data on how they grew and how they survived. We also needed to understand their needs, understand what it is that these species were going to thrive in the culture, because IMIPAS was established at first to work in a coral culture program. So we had corals, we knew everything about the corals and what they needed, but now change it to a whole different kind of animal. So just adapting, creating new shelters for them, because again, through their molting, they're getting out of that skeleton, they become very weak. So we designed, for example, these plaques with kind of like little apartments for each one of the juveniles for that very, very sensitive and kind of weak stage when they molt, to be protected a little bit more. So there was a lot of learning. And one of the biggest parts in which we had to focus on was their feeding, because we kind of wanted to really know how impactful they were going to be, and how, if everything and all the theory that we had done and like the studies with the pilot project, how much they really ate. So we focused on the adults, we focused on the smaller juveniles, and even in the tiny juveniles, like the video in the top right. And we try to quantify how much algae they were eating for biomass of crabs. So how much algae was each crab eating, depending on their size. And we got to even quantify that they eat up to 20% of their body weight in algae a day. That was an amazing find and very, very surprising to put it in numbers like that. So that was incredible. And even more so than knowing their impact was also closing the reproductive cycle. Closing the reproductive cycle for non-aquaculture specialists means that from the larvae that are born, from the eggs that hatch and the larvae that are born in our aquaculture systems, they grow, they develop into a sexual mature organism, and then they can reproduce, and then that way close the circle, as it is called, the cycle, sorry, as it is called. Not only were we able to close this cycle and have this production of crabs, but we were able to start outplanting some crabs onto the reef, which was already starting to do what the whole project kind of wanted to achieve, you know?
Yes, exactly. Those achievements or even success, I think, are amazing. And on the video, you can see how we are introducing those crabs. And so far, we've introduced 175 crabs, juvenile, well, not so juveniles anymore, right? Young crabs to the reef for them to begin their mission. And on top of being able to close that cycle of reproduction, the production in itself is now more consistent. We are able to produce in a more consistent base young crabs, right? And we are even now trying to see until what size we can even grow them. So that is amazing. And also that based on all those knowledge or experiences that Sara was explaining earlier, we are now wanting to replicate and see how it can be adapted also in other areas of the Mesoamerican Reef. And we are now starting 2 pilots in Belize, in Tenerife Atoll, and in Honduras, in Cayos Cochinos. So this is also very exciting. And as Sara was saying, they are eating about 20% of their mass. So we've calculated that from those 175 crabs that are now in the reefs in the Mexican part of the Mesoamerican Reef, they should have already consumed about 30 tons of fleshy macroalgae, which is about 7 elephants. So I think that's not nothing, but a pretty good result so far based on that crazy idea and that crazy dream that we had with the team at IMIPAS and Healthy Reefs.
Yeah, definitely. And it was very promising and inspiring when we found those numbers, but we've also had a lot of difficulties and uncertainty because even though it's been fairly easy, to put it like that, even though we've worked very hard for it, one of the biggest challenges, as you can see in the video, is that crabs will eat each other. So remember when I told you that they molt to be able to grow? They have a very, very soft outer skeleton as soon as they molt. So any other crab that is hungry can just come and start eating. And you can see in the video very, very clear how even a smaller one is eating a bigger one. We've also had some uncertainty on possible diseases and bacteria or lack of feeding or proper feeding because we were just starting and didn't really know. Okay, they eat algae, but do they need anything else to be able to grow well and to grow healthy? So in this picture, you can't really tell because you're not used to seeing crabs, and in a still picture, it's hard to tell, but there was a period when we had this event that we called zombie crabs, in which crabs would become very lethargic and very, very kind of clumsy. They would kind of like just fall face forward and just stay there. And then I would just come and check and imagine that they were dead, but they weren't dead. They were just kind of like not acting. And when you approach them, they would kind of like react again. So with some help from a researcher in Wadi University, she came and did a whole dissection of these zombie crabs to kind of try to find what it was that was going on. And she did all this dissection and like try to find parasites or a lot of like bacterial infestation or anything abnormal. And she wasn't able to give us any conclusive reason for this behavior. So that just kind of left us kind of happy because there weren't any parasites or bacteria, but kind of like unsettled because we didn't know what was going on. With that event, we were able to understand that it was a little bit of the diet that we had to improve. And since then, we haven't had a lot of problems. But a big issue with all of this is that all of that uncertainty requires a lot of tests, requires a lot of bacteria analysis, just like tissue samples and all of this like very technical lab work And all of that is very, very expensive. And Meli, I think you are more experienced with all the funding related difficulties of the project. So maybe you can tell us a little bit about that.
Yeah, exactly. Well, the whole project really began like as a collaboration with IMIPAS, and we all like kind of put in kind contribution, right? And since the beginning, well, Healthy Reefs has been trying to fundraise for the project, and really we have been dependent on philanthropy. All the project has been funded through foundations, through donors, etc. And we have been applying to calls, etc., and making the reports, and you know the whole philanthropy associated funding, well, administration, etc. But really, now that we have a bit more experience in that production system, and taking back our first idea of maybe being well, a new source of income for local communities, that's where the MAR+Invest project came really into the picture and aligned perfectly with that project, because we begin to think about the project with different eyes, right? It needs to be shifted. It needs to shift a bit its orientation, and we need to move out of our comfort zone, because we are like really good at well, thinking about monitoring and growing the crabs, etc., right? And money and the conservation side of it. But sometimes we are a bit well, it's more difficult for us, right, to think about in finance terms. And so the MAR+Invest is an initiative between several partners of blended finance mechanisms, and that basically aims to look in the market to those businesses, to those initiatives that have a positive impact on the Mesoamerican Reef, right, on the reef communities. And so it's MAR Fund, the Mesoamerican Reef Fund, is provides the technical assistance, but also Fondo Mexicano and Sureste Sostenible are building or are giving the Build and Connect program, which is a leadership program to help raise more initiative, right, to help identify those persons with a project. Wiwala is the investment banking group, and that really look into businesses that are a bit more mature to see how which tools, what finance tools that can help them increase their positive impact on the reef. And also New Ventures is leading the acceleration program. So it will they take businesses that are maybe a little less developed and help them through mentoring, through consultation, etc. How they can also begin to be more productive and be more increase that impact. And us at Healthy Reefs for Healthy People, we try to monitor those impact, those collaborative impact of all those businesses, market solutions on the reef, actually. So our business, our pilot with that project came the idea of a business, right?
Yes, definitely. And well, I was very lucky to be part of the Build and Connect program from Sureste Sostenible and Fondo Mexicano. And as you said, you know, it's a little bit about changing the way you view your project and changing sometimes the way or the angle in which you're looking at it. So that's when, with all the abilities and all of this new information and this new viewpoint that they started introducing into our lives and points of view, is when we started thinking about, okay, this crab, I think, or we think, has a lot of potential. I mean, it not only has a very important and impactful role in the reef, but as we have come to call it, and an idea that came a long time ago, it's a delicious solution. And as you can see, fishermen already collect them from the ocean, and you can see a very tasty dish, a very delicious dish from them. And it can be sold for around $200 a kilo of crab. We know that these big males weigh around 1.5 to 2 kilos. So, you know, you can immediately tell that it's going to be delicious and it's going to be a very good solution. So we started studying the market a little bit, and we know that we have already kind of not a competitor, but another product that has paved the way, at least in the north of the Yucatan Peninsula in Quintana Roo, which is the Alaskan king crab. And the thing with this crab is that it's coming from Alaska. You know, it will never be fresh. You will never have a fresh king crab from Alaska in the Mesoamerican region, you know?
And speak about carbon footprint.
Of course, exactly. How much carbon footprint is it taking to come from Alaska, and all the transportation and just the trip itself, you know? So here was this initial solution where this crab is here. It's very, very similar in its taste. It's a little bit smaller, but it's going to be fresh. It's going to be locally produced. It's going to be with a sustainable, impactful mission. So it was just kind of like all coming together. And so from that first aquaculture pilot project, where we were just going to focus on improving the health of the reef and restocking a valuable fish resource, it turns now into, when we changed that shift, when we shifted the way we thought into, okay, we can actually sell this crab, and we can sell it for a decent amount of money, as we have seen from the market studies that we have done. So we can sell it to high-end clients like restaurants and hotels. We can produce a little bit of money that we can invest on continuing the research to scale up our production, to be able to continue introducing organisms on the reef, and then a little bit to like continue the production of the king crab, to continue that business kind of cycle. So it was kind of like amazing to just be able to find this little way in which we could just like complement both sides. And Melina, you were going to say something? Yeah.
Yes, no, and it is exactly where the MAR+Invest project came to align with that, because thanks to that project, now we have a consultation about a business plan. We are improving the feeding of the crabs, etc. So it really come to add to that mission, or to that pilot idea we had at the beginning.
Yeah, absolutely. Because while we are very, very scientific, and then just being able to come into that world, it's not easy. So they have really helped us, just like, first of all, open our eyes and change the way we view our project, but also gave us the tools to be able to come into this business world and do it in the best way possible, you know, always with an impactful idea that will going to benefit the ecosystem or local populations. So we have learned a lot, but we still have a lot of work to do, and a lot of very important next steps. And we were able to identify kind of like the two paths we need to work on, which is, of course, the production of the crab itself. We need to scale up the production, and we have set some specific goals to be able to start addressing this need to scale up the production, which is exploring feeding alternatives, maybe making more efficient feed so we can have more efficient growth, and that way we can also increase juvenile survival. And we, of course, have a lot of continued research that we need to do on the crabs themselves and on the production that we have. And then, of course, a lot of the business side that MAR+Invest and other programs have kind of come into our brains, but spin out this project into a commercial enterprise and develop sales relationships and all those skills that are required for that. Explore and develop all the business plan options and all like the mixed finance and all that comes in with having a business. So we can establish like a for-profit brand that can, as we said, reinvest into the project itself. But I think one of like a very important next step is to involve the people. And that's why I want to ask everyone if you will join us and you will try our delicious solution, and more importantly, help us continue saving the reef. It is very important to get the support of the people. So thank you so much for being here. All of the research that we do doesn't do anything if we do not get other people involved. So thank you so much for being here. Thank you for all the funding that has come from all our partners in different ways, not only financial, but in-kind contributions that they have made. And Melina, thank you so much for being here. This project was a little baby when we started, and now I think it has grown incredibly thanks to the work of very, very dedicated women and some men, but mostly women. So yeah, thank you so much for being here. Thank you for the opportunity. And that's it.
Thank you, Sara. And yeah, as you said, this is like some of those hope spot project, right? Being able to give back to the reef that is doing so bad in the world lately. It's something that really, well, I don't know, lightens, right, your day and make continue and look for more and keep going, right? So, well, as you said, thank you to all our donors, and yes, congratulations, and let's go for more.
Let's go for more.
Melina, Sara, thank you very much for your presentation. Of course, I would like to try this delicious solution. Sounds like a good plan. Thank you for sharing with us your enthusiastic and your knowledge about this Caribbean King Crab project. And thank you again, and see you later.
Thank you so much, Natalie, for the invitation and the opportunity.